I'm Igor, and today we're going to talk about data reliability engineering. And I know it's right before lunch, so I'm going to try to get through this, and we'll do some Q&A at the end. So why are we even here, and who am I, and why does this even matter to anybody? So I'm Igor. I'm the co-founder and CTO at Bigeye. We are a data observability platform. Before Bigeye, I was at Uber. I was one of the first people called a data engineer at Uber, set up a lot of the original data warehouse stack, and built a lot of internal data tooling at Uber. Data reliability was a problem there. It's a problem at every company. If you work for a company, you probably have data problems. And this is why Bigeye got started. And let's talk about specifically what kinds of problems do we mean when we talk about data reliability problems. Well, every business has different needs for their data. It can span everything between actual financials, billing customers, making sure that your accounts payable are getting tracked. In the Uber example, are drivers getting paid? We have incentive programs, and if those incentive programs don't get computed correctly, then drivers don't get paid the right amount. So data reliability was really important for us then as well. On top of that, you might have compliance risk. Everyone here probably has had to go through some sort of audit, whether that's SOC 2, ISO 27001, whatever it is. You need to make sure that the data that you're using for all of your business processes, whether they're revenue generating or not, is reliable and compliant. And finally, and this is the most underrepresented part of data reliability, is the actual wasted time from engineers and other employees in your company. If you've ever looked at a broken dashboard, if you've ever had an executive that got a report and they said, I don't know if this dashboard looks correct, something looks suspicious about this, they're going to go message the data team. The data team now has to go back and run some queries, figure out where it's coming from. All of this time is being wasted. The data engineer's time is being wasted because they can't pinpoint where something's going wrong. The executive's time is being wasted because they have to manually now check the dashboard, and now they distrust it, and now every week they're going to spend a couple of extra minutes trying to figure out, is the data still wrong? And if you add up all of this wasted effort and all of this risk, there was a report, I'm pretty sure this is Gartner, and I really wish I cited it because I don't remember, but every year, poor data quality costs companies, on average, $12.9 million. Now, Bigeye is a small company. This is effectively our annual, close to our annual spend, not exactly, but this is a very large number. For large organizations, Fortune 500s, this can get into hundreds of millions, if not billions of dollars, especially when you're talking about revenue issues coming from data reliability. So let's talk about how we even got here. Why is data reliability important now? Why haven't we been talking about this a few years ago? Well, data engineering and the data landscape is evolving similarly to how software evolved, but with a bit of a delay. So if you think back to early 2000s, software was built and deployed on bare metal racks that sat in a closet somewhere, and you had to manually pick up a server and stick it in the rack, and if you needed more capacity, you go and you buy another server and you stick it in the rack, and you wire it up, and that's where you deploy all of your software. Then AWS came along and said, well, push a button and get a new server and get your database set up, and it's all going to work, and it's all going to be well connected and networked, and you can deploy your new application in a matter of minutes. That was impossible. And so now a bunch of software engineers are saying, great, I can build software faster. So I'm going to go build 5 applications and deploy all of them. But now you have the problem of, like, how do I actually automate that deployment? How do I make sure that my applications get out? So now you have all the CI/CD pipelines, and you have GitHub, and you have Jenkins, and I know Jenkins a little before this, but illustrative point. You use the deployment pipelines in order to automate a lot of the processes that didn't need automation before. And now that you've automated those processes, what's the next problem that you encounter? Well, are my applications up and running? Are they serving the customer's use case? Are they what's the latency on them? What's the QPS? Is something falling over or not? That sort of monitoring used to be reported by a customer. Someone goes out there and says, hey, I can't load your website. Great. Someone's going to have to go and check and maybe restart a server or two. So you have companies like Datadog, New Relic, AppDynamics, Dynatrace, who built monitoring and observability for the infrastructure and application layer. So now that we got there with the software, in the software space, let's track this again, but in the data landscape. So we start with cloud warehouses. Going back to the infrastructure talk, when I started working on data warehouses, I used Vertica. And Vertica was deployed on physical machines in a data center. You had to install a package on all of them. You had to make sure the networking was right. This was a complete nightmare. And circa 2012, 13, you started getting Redshift. You started getting Snowflake. You started BigQuery eventually got there as well, where the infrastructure for data became easy. When we wanted to set up our data warehouse, I went to Snowflake, and I typed in my credit card number, and I clicked go, and I could run a query 2 minutes later. It's amazing. Would not be able to do that 10 years ago. So now that I have infrastructure, what's the next step? Well, get the data in the infrastructure. And so you have your fivetrans and stitches and segments and all of that, and you're getting the data in, and dbt is helping you transform it. And this is all fine and dandy, but now because it's so easy to get stuff in, and it's so easy to spin up new data warehouse infrastructure, now we have the last problem, which is reliability. How do I know that my data is there, that it's on time, that it looks like what I expect it to look like, that it's serving the need that I want from it? And data reliability wasn't a problem in the past because data could only scale as fast as teams could scale. If I have to, in order to get a new data source, write new code, maybe even plug in a new machine to expand my cluster because I don't have enough space to store it, takes time. There's processes. We can work through that. But now that data is scaling, you need processes to ensure data reliability at a much more automated and reliable way than you did before. So this is the typical pattern that a company follows when they start setting up their data stack. So we talked about infrastructure. That's Snowflake and BigQuery and all of those. And you have your compute, and you have your airflows to orchestrate your stuff, and you're getting data in. And next thing you do is you completely skip over all the operations part of this, and you say, well, I want to build dashboards and machine learning models, because that's the cool part. So then you start building dashboards, and you get Tableau, and you get Mode, and you get Looker, and you just start presenting these dashboards, and then maybe you get some machine learning going, and you're training all these models. And then you realize that this isn't sustainable. Nobody knows where any of these dashboards are. Nobody knows what they mean. Nobody knows if they can use them, if they can trust them. Nobody knows how their changes are affecting anyone else in the organization. And then everyone ends up backtracking into operations, which is discovery. Data catalogs nowadays address a lot of this. Ownership, data modeling, and obviously reliability is part of this. Addresses quality, addresses lineage. Where is the data coming from? What is it affecting? All of this tooling necessary to operate your data team and your organization at scale is an afterthought. And that's a problem when you're scaling much faster than your team is scaling. And we here at Bigeye believe that you should build the pyramid in the right order and definitely not forget about operations halfway through. But let's move on. This is the way that companies build their data stack. So then, if this is what the stack is, then what is data reliability engineering? What are we going to talk about today? Well, let's go back to site reliability engineering, SREs. Go back to that slide where I talked about how software became more automated, easier to deploy, easier to monitor. Because there was so much software, companies now needed to have processes and teams in place in order to know how to operate and work with that software. And those teams started becoming called site reliability engineering teams. And Google wrote a giant manifesto on how to do site reliability engineering. And in that book, they talked about the 7 principles of SRE. And it all boils down to the concept of treating your applications as with the same sort of intentionality that you would treat any other business process. And creating scalable processes and solutions in order to create reliable software systems. And so these are the 7 principles. Embrace risk. Everything's going to break. Just accept it and learn how to deal with that. Setting standards. You need to set standards, otherwise you don't know what you're measuring yourself against. What is good? What is the right standard for your data, for your application? Reducing toil. Nobody wants to push the same script over and over again. If you get woken up at 2 a.m. because you're getting paged because the system is down, you don't want to think what the next step is. You want to go push a button and have something solve that problem for you. Monitor everything. There's a lot of systems out there, and we should be monitoring everything because the interdependencies are so complex that nobody actually knows about them. And if you're not monitoring everything, then you're probably not catching the things that you need to be catching. Using automation. This goes a little bit hand in hand with reducing toil, but automating as many processes as possible helps you overcome the barrier of knowledge, and especially tribal knowledge within an organization about how to fix things if you can automate the fixing of those things. Control your releases. Don't make changes without knowing what those changes are going to do. I briefly mentioned lineage. I know lineage is a very popular topic in the data space right now. Part of the whole point of lineage is understanding where are things coming from, where are they going to, so that when you are making changes, you're intentional about your changes, and you know what your changes are going to affect. And finally, favor simplicity. Systems shouldn't be complex. Using complex systems makes them less reliable, and you want reliability by way of simplicity, because if you can understand a system and you can understand how it operates and what it impacts, you can then make it much more reliable. So this is SRE and the principles that SRE introduced. So now let's talk about data reliability engineering. So DRE, how we've summarized it, is treating data quality like it's an engineering problem. Rather than approaching data quality from the perspective of, well, there's going to be an analyst, and the analyst is going to look at the dashboard and they can figure it out because they can run the queries and they know the data, that doesn't scale. None of these principles apply to that process. If you treat data quality like an engineering problem, then what you're actually doing is you're saying, I will build solutions and systems and processes around this that are repeatable, that are reliable, that I can actually trust not just myself, but the rest of my team to be able to execute and ensure the reliability of my data. So going back to that pyramid that I showed earlier, data operations is a really broad space. It covers a lot of territory. Data operations covers everything from, as I mentioned, discovery, access controls, privacy, security, how the data is being used, the performance of your queries, optimizing that performance. There's a lot of things in data ops, and data reliability engineering is really a part of it. It talks about the practices and the tools that you need to have in order to ensure a lot of the reliability that is core to the rest of the data ops tool chain. So when we talk about data reliability engineering, we're talking about practices like setting SLAs for your products, applications of SLAs, why don't your dashboards? Instrumenting this, having incident management processes, monitoring, tracking alerts over time, tracking response rates, having runbooks, all these processes and tools that are necessary, but this is not the whole picture. And we can have another talk about data ops at some point in the future, but that would take a lot longer than 45 minutes. So I've talked a lot about these conceptual terms of DRE and practices and tools, and you're like, well, that's great, Egor, but what am I actually going to do with this? How do I get started? Well, let's look at some examples of DRE in the real world. circuit breakers from Intuit. There's a little blog post link. If you Google circuit breakers, Intuit circuit breakers, you'll find it. So circuit breakers is a tool at Intuit that automates the data flow based on some quality checks. Circuit breakers allows you to define conditions under which data is not fit for use, and it automatically stops the pipeline and says, nope, this data is bad, I don't trust it. If I keep the data flowing, then there's going to be consequences downstream. What principles is this touching? Well, embracing risk. Data is going to break. They have accepted the fact that data is going to break, so they need to do something about it. They automate the stopping of the process. This isn't an alert that gets sent to a data engineer who then has to wake up at 2 a.m. and push a button to stop a pipeline, because nobody ever wants to do that. And then you're going to forget to turn on the pipeline again, and then the data's stale, and then you have an even bigger problem. So automating the start and stop process of the pipeline is really important in this case, especially at the scale that Intuit is operating at. And finally, favoring simplicity. This is a diagram from their blog post. It's 2 boxes. This is about as simple of a process and a tool as you can get. Data is bad, stop the flow. Data is good, start the flow. You don't need a complex system in order to start practicing and having better, higher reliable data. Midas from Airbnb. So Midas is a way for that Airbnb allows you to certify data sets as effectively golden. Part of the certification process includes understanding what does the data mean? Does it actually comply with the expectations of the business for that data? And also tracking the reliability and accuracy over time, because if it becomes less reliable, then it shouldn't be a golden data set. So this is actually much more interesting because this is less automation. This is much more policy. This is a lot more about the practices that the organization has actually put together in order to make sure that their data systems are reliable. What principles are we talking about here? Setting standards. They set the standards for what does it mean for a data set to be golden? What do you have to have? What do you have to ensure about your data for it to be considered certified by the Midas touch? I'm sure there's a pun there somewhere. Controlling releases. You can't just change a Midas data set because it's being tracked. You know what the expectations about it are, and if those expectations aren't met, then you can't change it. You can't also just say, yes, my data set is golden and you can trust it. It has to go through a process. You have to control the certification so that you don't get a ton of erroneous data that nobody actually understands and nobody knows who certified it. And finally, again, favor simplicity. There's a little box on a page somewhere that just says, this is certified, great. You don't have to have all these complex integrations. You don't have to push this information out to users in a million different UIs. You have a single place, you put a little gold stamp on it, you call it a day. I mean, I am oversimplifying. I am sorry if there are any Airbnb folks here. I have not worked with this directly, but I am paraphrasing. Finally, Uber data quality. Everything at Uber started with a U, so UDQ from Uber. This is probably one of the more complex systems and examples. There's, again, all these have blog posts. You can look these up after the fact. Uber's system was more complex because it actually integrated a lot of the tools together in order to form this data reliability story. So there's a lot here about how the compute works, how the tests are being run, and how they're stored, and how they're changed over time, and where the lineage service actually talks to the testing service and understands the impact of it. The reason that Uber was able to do this is because there was a massive data team, and Uber built everything in-house. And so everything built in-house means that you can actually build all of these highly customized tools that interact well together. Much harder to do when you're starting to duct tape together different vendors and different pieces of open source technology. But if you have a concrete problem in a concrete domain, it becomes very easy to build these hyper-specific integrated tools. So what principles are we talking about here? Embracing risk. Uber had a lot of pipelines. They broke all the time. But having this tool, having this tool chain that allowed you to say, we understand that, and we just want to start tracking it. We want to make sure that we can react to it appropriately is extremely important for an organization that size. Reducing toil. This system, because it's so integrated, because it's so connected, reduced a lot of the overhead of collecting this information yourself. You didn't have to go run queries. You didn't have to go and figure out when was this table last updated, who's querying it, what's the upstream. The system provided you all that information in one cohesive view. And finally, use automation. This is all automated. The only interaction of the user with this system is through the configuration tools you see up top, the dashboarding, the quality tool that has the UI, and that goes through the APIs, and the system just handles the rest of it itself and just runs and works. Automating this means that I, as a data user, just have to define once what do I care about, and the system can take care of it itself until I tell it otherwise. So thanks for coming to my talk. Hopefully, you all learned a little bit something about data reliability engineering, and if you have been inspired to pursue the lofty goal of having perfectly reliable data at your organization, come to my office hours. I'd be happy to talk about how to make that a reality.
Awesome.